Okay, so in today's lesson we're going to carry on with area. This is the second of our lessons on finding the area of different shapes this term. What we're going to look at today is how we find the area of our different quadrilateral shapes. A quadrilateral is a four-sided shape. So in the previous video, and again make sure to watch that if you haven't already, we looked at how we found the area of squares, rectangles and triangles. So again, because we're looking at quadrilaterals, we'll do a quick recap on squares and rectangles. The area, if you remember, is quite simply defined as the space inside a shape. All we're going to do here is, again, just recap what we already know from the last lesson. Where we're finding the area of a rectangle or a square, what we do is simply multiply the base times the height. Okay, so this, for example, here is a square. I can tell all the sides are the same, base times height, and in the case of a rectangle, also just base times height. All right, so very quick example on this one, because again, we looked at this in the last video. Find the area of the rectangle. We have a rectangle here that is 3 meters wide and 2 meters tall, and again, units is important. Just setting out the formula that we're going to use, because again, I'll be showing you a number of formulas that you have to make sure to learn before going into your exam. B is the base, H is the height, so just substituting in, area is equal to 3 times 2. Okay, I've just taken the dimensions for my substitution from here. 3 times 2 is 6, and again, what's always important if you're asked to is to insert your units. So because we're dealing with meters here, our units for area will be meters squared. Okay, so again, just a quick recap there on squares and rectangles. Okay, now we're going to move on to some of the shapes we haven't yet looked at. And again, sticking with quadrilaterals, we will look at how we calculate or find the area of what is a parallelogram or a rhombus. Again, make sure to watch the previous video on how we identify our different types of shapes, parallelograms, rhombus. There is slightly different rules for each of those about what makes each unique. However, finding the area for either a parallelogram or a rhombus is the same. Okay, so if we look at this example, and again, this is a parallelogram, and I can tell it's a parallelogram rather than a rhombus because not all the sides are the same length, and a rhombus, the sides are the same length. We use this formula, so area is equal to base times perpendicular height. Now, again, I explained in the last video what perpendicular height is. If we are to look at our diagram here, the base is the bottom of the shape. If we're looking at in this orientation, we have two different types of height here. We have this, which is known as the slanted height of this side. So this side here, if we were to run a ruler along it, if it was drawn accurately, would be 3.7 centimeters. And then this is what we're looking for, the perpendicular height. The perpendicular height being the height from top to bottom straight up, being at a right angle to the base. So this is our perpendicular height, this 3 centimeters. So once we've identified that, very similar to rectangles, it's base times height. Of course, perpendicular height, we just substitute in our values. Area is equal to 4 being the base times 3 being the perpendicular height. Area is equal to 12. And again, this time it's centimeters squared because we've been dealing with centimeters. Okay, so that's how we calculate the area for a parallelogram or indeed a rhombus, base times perpendicular height. Moving on, the next of our quadrilaterals, and again I've written the formula here, is a kite. So again, just to explain very briefly what makes a kite, it has two pairs of equal sides. However, unlike the likes of a parallelogram or a rectangle, these sides are not opposite, they are adjacent to each other, they're beside each other. So these two sides are the same and these two sides are the same, and that's what makes this shape a kite. Now, slightly different, particularly because of the orientation of the shape, the way we're looking at it. It's not really a base, obviously, it's sitting on a point. Again, remember I was saying before, when you're doing questions like this, you can turn the page if it helps. We want the width and the height of the shape. So the width is from here to here. It's been given to us at the bottom of the shape here. However, these lines indicate that this is the width. So the width of this shape is 4 centimeters, okay? The height, And again, with all these, and I explained this in the first video, we're always looking at perpendicular height, so we're not using any of these slanted dimensions when we're talking about area. Is the perpendicular height of the shape from the bottom of it to the top, which is given along the side here, which is 7 centimeters. So width times height divided by 2, just a quicker way of writing our formula using the letters. So W, the width, is 4. The height, again perpendicular height, is 7. And we're going to divide that by 2. Alright, so 4 times 7 is 28, divided by 2 is 14. And again, because we're working in centimeters, centimeters squared. Alright, so that is our formula for the area of a kite. The last that we're going to look at in terms of our quadrilaterals is a trapezium. Now I'm going to actually just show you two methods of working out the area of a trapezium. The reason being, the formula for the area of a trapezium is a wee bit more complex, and in that regard I don't really like using the formula. I just use these 3 steps here. The formula is also given at the front of the CA exam, so it's there if you forget it. But again, I would always encourage you to learn it, because equally the way I've written it down is slightly different from the way it's written at the front of the exam. They write a half times a plus b times h. Multiplying by a half is the same as dividing by 2. Again, one of the reasons I don't really like the formula is to avoid that confusion, because there's a couple of different ways of writing it down. So if I was to use certainly this form of the formula, all right, and just to explain it, trapezium, what makes a trapezium unique, it has one pair of parallel sides, and that's it. That's what makes a trapezium unique. The other sides, so this pair, the 4 and the 7, they are parallel. This side and this side are not parallel. And then we have the perpendicular height that is given to us inside the shape here. All right. So within our formula, we have letters notated as A and B. A and B are the parallel sides. So we're using 4 and 7 for A and B. Doesn't matter what you call A or what you call B, A and B are the parallel sides. H, again, is perpendicular height. Again, we're always using perpendicular height when we're finding area. So this 6 millimeters here is totally irrelevant to what we're trying to do. And again, sometimes they put that in there just to throw you off or to trip you up. Again, always using perpendicular height. So once we've identified our dimensions, so I'm going to call the 4 A and the B is the 7 millimeter one. Again, wouldn't matter if you got those the other way around, but it is important that the 3 millimeters is our H. So A equals A plus B over 2, all times the height H. Okay, so substituting in our values, A was 4, B was 7, all divided by 2, multiplied by the perpendicular height, which is 3. Okay. So, again, just a little bit more working out involved with this. 4 plus 7 is 11. 11 divided by 2 is 5.5. And then we're doing 5.5 times 3, which is 16.5. And again, because we're working in millimeters this time, millimeters squared. All right? So that is how we use the formula. The other way is using these 3 steps, and this is when I'm working with trapeziums, this is what I like to do just to work out the area. For me personally, I find it a wee bit quicker and easier. Add the parallel sides, divide by 2, multiply by perpendicular height. I find it very easy to remember those 3 steps, and again, I think it just cuts down on the amount of working out. Again, if you're not comfortable with algebra, substitution mightn't be your strongest suit. So if you're like me, you just like to use the 3 steps. So adding the parallel sides, 4 plus 7. 4 plus 7 equals 11. Then we're dividing by 2. So 11 divided by 2 equals 5.5. And then we're going to multiply by the perpendicular height, which is 3. 5.5 times 3, which again equals 16.5 millimeters squared. Okay? So that's the other way of just using the steps rather than the formula. Personally, I prefer this way. Again, you can see it's a wee bit shorter, quicker, gets you to the same answer at the end of the day. And again, it's totally up to yourself if you like using the formula, setting it out that way, or if you just like following these 3 steps. with all these types of questions, I will prepare some practice questions for the end of the video, and if there's anything you're unsure about, just feel free to ask.